This is Sandeep from third year Artificial Intelligence and Data Science Department. Now I am going to explain about the implementation of hidden Markov model, which is experiment 4 in applied artificial intelligence. The main objective of this experiment is to implement the forward algorithm to compute the probability of an observed sequence given in a hidden Markov model, which is a HMM. Additionally, the experiment aims to determine the most likely sequence of hidden states corresponding to the observed sequence using the calculated forward probabilities. Now I will be explaining step by step observation of the program. First, we are importing NumPy library, like we are importing the necessary libraries we need. Next, we are defining the transition matrix using np.array. Next, we are defining the emission matrix using np.array. Next, we are defining the initial probabilities in matrix form in or in array form, and next we are defining the observed sequence in the array form. Uh, the transition matrix, emission matrix, initial probability, and observed sequence will be the uh, like inputs of this experiment. Now we will be seeing about the forward algorithm initialization. In the start, we will be initializing the alpha matrix to score the forward probabilities. Next, like we'll be calculating the first row of alpha matrix. Like we'll be setting the initial step of alpha matrix using the initial probabilities and emission probabilities for the first observation. Now we'll be calculating loop through the rest of the observed sequence and calculate the rest of the alpha matrix. Like for t in range 1 comma length of observed sequence, for j in range length of initial probabilities, alpha t comma j equal to emission matrix j comma observed sequence into np dot sum of alpha t minus 1 is to till the end of the matrix into transition matrix uh, from start to j. Uh, Here we'll be using forward algorithm recursion, iterate over each time step and each state, update the alpha values using the transition and emission probabilities, compute the total probability, sum the final alpha values to get the probability of the observed sequence. In the last, like print the most likely sequence of weather states. For each time step, determine the state with the higher alpha value. Map the states to weather conditions and store the result. The execution and results are first we'll be talking about the execution. The program initializes the forward probabilities using the initial state probabilities and the emission probabilities of the first observation. It iteratively updates the forward probabilities for each observation in the sequence. The total probability of the observed sequence is calculated by summing the final forward probabilities. The most likely sequence of weather states is determined by comparing forward probabilities at each time step. The results are the probability of observed sequence is printed. The most likely sequence of weather states corresponding to the observed sequence is printed. With this HMM model, we can build applications like speech recognition, bioinformatics, natural language processing, financial modeling, and weather prediction. Thank you.